What's up, everybody? It's Dan from Sage Math Tutoring, and I'm back with another video where I'm going to just cover a review sheet for a quiz for a student of mine. So let's actually dive right in. It's actually a pretty big review sheet, so I'm going to move as quickly as I can under the assumption that my student sort of kind of knows what's going on with these and maybe just needs a refresher. So let's take a look here. I think it's very clear that we would need to distribute that. It is the case there's an invisible positive 1 here, and that would distribute as well. But, typically we don't really think about that because it's just an invisible positive 1. So we would have 5 plus 5 n cubed minus 1 plus 3 n cubed. We have a like term, like term. We have a like term, like term. The red underline like terms become this, and the green underline like terms become that. So that should be the answer there. Over here, similarly, it is kind of like distribution. But, when it's sort of a plus sign, you don't really need to necessarily represent this step. It's kind of understood that you would be multiplying 1 times everything and then dropping the parentheses as a result. So we would have 6a minus 3a squared plus 2a squared minus 3a. These happen to be like terms. The double underlines happen to be like terms. So we are looking at negative a squared plus 3a. Okay, so that is that one. Looking over here, similarly, we could kind of drop the parentheses and just say that this is the situation we're dealing with, and single underline like terms, double underline like terms, we're looking at negative x squared plus 7x, I do believe, unless I'm making a careless mistake, but I don't think I am. Over here, definitely distributing that, no question. So we would have 2x squared plus 4x cubed plus 3x to the third minus 8. Single underline like term is all by itself, double underline like term, and then a blank like term. With the double underline like terms, we're looking at 7x cubed plus 2x squared, and then we have minus 8 right here. Just sort of distributing that invisible positive 1 into each of these would just have us rewrite it without parentheses. We're looking at this. And single underline like term for these, double underline for that. These would cancel, and then we would just be left with 4n to the third. Okay. These are the steps that I think the teacher would like to see, for the record. I think my student watching understands. We can distribute that. So we have 10 to the 4 plus 11 minus 11p to the 4th plus 13 plus 16p squared. Single underline for those, double underline for these, and the p squared is sort of by itself. So with regards to the single underline, we are looking at negative p to the 4th, sort of going down by exponents, would be plus 16p to the second, and then the double underline like terms give us plus 24. That should do it for that. Okay. Well, yeah, just, same deal. I think my student watching understands. Just to rewrite it in this case. And single underline for the x to the 4th, double underline for the constants, and then blank for the other ones. So we have 21 x to the 4th due to the single underline. The blank one is all by itself, so that's 6x cubed. And then the double underlines would give us a negative 4. Hopefully that makes sense. Okay. Over here, of course, distributing. And then rewrite this part. Minus 14k cubed plus 2k minus 9k to the 4th. Single underline for these, double underline for these, and blank for the other. So we have just k to the 4th, double underline, we give us plus 3k to the 3rd, plus 2k. Hopefully that makes sense. So that does it for that one. Oh, more. More of the same. Awesome. Okay, so rewriting this. Um, I mean, it is an important skill. So, I mean, if you don't know how to do this, then it's going to be problems. So, single underline for those, double underline for the r cubed, and blank for the constants. With regards to the double underline r cubed, we're looking at 7r cubed. Single underlines would give us a plus 13r squared, and the constants would give us a plus 7. Hopefully that makes sense. For my student watching, I might make a careless mistake, so partly because I'm moving fast. So, just make sure you agree with these answers. All right, so we have 9n to the fifth plus 2n minus 11, and we have negative 11n plus 7n to the fifth minus 3. So the single underline for the n to the fifth, double underline for the n's, and blank for the constant. So with regards to the single underlines, we're looking at negative 2n to the fifth. Double underlines would give us negative 9n, I do believe. And then the blanks would give us negative 14. Hopefully that makes sense. Okay. This is the first of its kind in the sense that we are not only being expected to distribute, but we will be multiplying a v times a v. So you do have to be on your game with that. So 6v times 2v, you must be on your game. That is 12v squared. Hopefully that makes sense. The 6v times the positive 3 is just plus 18v. Hopefully my student recognizes that. So very quickly, v times v, hopefully that's clear. That's v squared, isn't it? Just even common sense wise, right? V times v is v squared. Now, the sort of official way of understanding it is that v to the first power times v to the first power, you would keep the base but add the exponents. Okay, so that's that. Distributing this, of course, would give us negative 35v, negative 35v minus 56, and believe it or not, that is all we need to do. Okay, so this is where it's getting a little crazy. I'm gonna say when you have this structure where it's just a nice little thing on the outside, which is like what we just did, the pattern I want my student to recognize is, something like this, right? But maybe there's three things in here. I don't know, and then it could be like that, right? So that's the distributive property. My student is probably very familiar with that. I think when it's the case that we have something like this, where in other words you have two binomials getting multiplied to each other, well, that would be FOIL. Okay. For my student watching, if you have something other than that, for example, this, or even this, you can use the box method for these. So for my student watching, that's at least three skills you need, right? Regular old distribution, we'll call this the same skill. Foiling, which kind of is the box method in disguise. But then there's the box method here. Now, for my student watching, if you don't know what I'm talking about with the box method, I will explain soon. Okay, so foiling would be for, in this situation, right? Because that's a binomial times another binomial. So let's take a look. FOIL, first, outer, inner, last, right? F stands for first, O stands for outer, I stands for inner, L stands for last. So first times first would be these, right? So we're looking at 8n to the third. Please, for my student watching, be careful with multiplying n squared times n. That is, once again, keeping the base, but adding the exponents. That exponent of 2 plus that exponent of 1 that's hovering above the n becomes that. Outer stands for the two outside things. So that would be plus 16n squared. Hopefully my student agrees. Inner stands for the inside things. So that would be plus 2n. And then finally, of course, L stands for the two last things. So that's 1 times 6, which is plus 6. And it turns out that there are no like terms to be combined here. So believe it or not, you're actually done with that. Of course, you have to always be careful. Don't rush to that conclusion. This will require more simplification at the end, but it's still a FOIL. First times first would give us 48p squared. Outer times outer would give us 16p. Inner times inner would give us negative 12p. And then we have negative 4. So we have like term. Of course, 48p squared plus 4p minus 4. And then you're done. Hopefully that makes sense. Okay. Over here, still foiling because it's a binomial times a binomial. First times first would give us 30p to the third. Outer times outer would give us negative 48p squared. Inner times inner would give us plus 40p squared. Last times last would give us negative 64p. We do indeed have like terms here. So we have 30p cubed minus 8p squared minus 64p. And I do think that's as far as you can go with that. This would be FOIL. First times first would give us 16a to the fourth. Outer times outer would give us negative 10a. Inner times inner would give us negative 8a cubed. Last times last would give us a positive 5. Now, if we want to have good manners, maybe rewrite this in descending order of exponents. Okay, so that's that. Is that everything? Yes, it is. Okay, keep going. This is really FOIL in disguise. Now, there is sort of a special pattern that you could memorize to do that, but I always thought that foiling just makes it a little easier because it's one less thing to remember. First times first gives us 16p squared. Outer times outer gives us this. Inner times inner gives us the same thing. Last times last would give us plus 1. Of course, combining like terms, we have 16p squared minus 8p plus 1. That should do it. Also FOIL, right? Still a binomial times another binomial. So first times first would give us 35x to the third. Outer times outer would give us plus 42x. Inner times inner would give us negative 30x to the fourth. Last times last would give us negative 36x squared. And putting that in descending exponent order, it would be that plus 35x to the third minus 36x squared plus 42x. So I do believe that's all we need to do there. Okay. Okay, this is the first time that there's an opportunity to use the box method. Now, for my student watching, I'm not so sure if your teacher wants you to use the box method. What I can tell you is one way of going about this is to multiply this times all of the things and then write that down. Okay. And then you can multiply this times all of the things and then write that down. And then just combine like terms. Okay. Now, that's fine. However, many people and many teachers do like the box method, and it's possible that your teacher likes the box method. I don't know. But I just want to say use the box method only if you feel confident that it's not going to count against you. Okay. Now, I'm going to go ahead and use the box method on these problems, partly because I'm operating under the assumption that using the box method is okay, and partly because the box method is just superior, okay, in terms of not making a mistake. So, how do you do it? Well, you put the long thing across the top. That's this. And you just kind of list the terms. It's a 6a squared, it's a negative a, and it's a positive 3. So I just simply write the terms. And then down the side, I write these terms, the other terms. And I make a box. So what goes in the first box? Well, it would be the product of these two. So 6a squared times 4a is 24a to the third. In this box, it would be negative 4a squared. In this box, it would be 12a. In the box on the bottom left, it would be 12a squared. And this box, it would be negative 2a. And then in this box, it would be 6. Now, very often, however, not always, but very often, the sort of diagonal relationships are going to be like terms. Okay. And that makes your life easier because then you can see, okay, well, 24a squared is just by itself, right? Or a to the third, rather. We will be combining the two blue circled like terms. That's going to be a plus 8a squared. We will be combining the two green circled like terms. That would be plus 10a. And then we have a plus 6, and that's it. Okay. So that would be the solution there. If you were to not use the box method, you would multiply this times everything and then add that to this times everything underneath. But if you're going to use the box method, it would be negative k squared, negative k. We'd have a 9. You'd have a 7k. You'd have a negative 13. 7k times negative 7k squared is negative 7k cubed. This would be negative 7k squared. This would be 63k. This would be positive 3k squared. This would be positive 3k. And this would be negative 27. And do we have like terms diagonally? Yes, we do here. And it looks like we do here. Now, once again, you don't want to just assume that. It doesn't always work out that way, but very often it does. So then writing the answer should be easy. Negative 7k cubed, it's by itself. The blue circled like terms would give us negative 4k squared. The green circled like terms would give us plus 66k. And then we have minus 27. And then hopefully we are getting a 100. Same deal, except now they put the long one first. I would still advise you to do the long one across the top just to keep it the same as we proceed. So I think my student watching would agree. This is 6n to the 3. This would be 36n squared. This would be negative 24n. This would be negative 10n squared. This would be negative 60n. This would be positive 40. And then we have diagonal relationships here. So the final answer would be 6n cubed plus 26n squared. And then the blue relationship gives us negative 84n plus 40. So that's that. Okay, FOIL again out of nowhere. However, the teacher is also expecting you to realize that even though you could FOIL this, this is still of the form a minus b times a plus b. Now, hopefully my student watching recognizes that that's going to be a squared minus b squared. So in other words, this is going to be something squared minus something squared if we want to make it easy on ourselves. Well, what is the thing that goes in the first parentheses? This blue 10x goes in the first parentheses. What goes in the second parentheses? This green 11 goes in the second parentheses, okay? And what does that become? Well, that would become 100x squared minus 121. It's possible the teacher does want you to spot this pattern where it's the same thing here and here, and it's the same thing here and here. The only difference is this is minus and this is plus, or vice versa. So when that's the case, you adhere to this structure and you can kind of get away with just throwing it into parentheses like this. And for my student watching, please understand that the 10x itself was wrapped in parentheses, which means this exponent of 2 gets applied not only to the x, but it also gets applied to the 10, which is why it became a 100x squared. However, you might be wondering, well, couldn't I have just FOILed it? I mean, you did write FOIL on it after all. Well, yes, you could have FOILed it. First times first would give you 100x squared. Outer times outer would have given us negative 110x or positive 110x. Inner times inner would be negative 110x. Last times last would be minus 121. These would have canceled, which by the way will always happen when you have that pattern. And then we have this, which is the same answer. Okay. So that is how you would do that. Problem number 23. I would actually advise the box method on that, believe it or not. Now, let's say you weren't going to be using the box method. What the teacher might want you to do is multiply this times everything. And then you're going to multiply this times all the things. And then you're going to multiply this times all the things. And you're going to have a big string of gobbledygook, polynomial. And then you would have to combine like terms and all of that. All right. Now, again, that's very clunky, a lot of opportunities to make a careless mistake. It also takes up a lot of room in the paper. So I'm going to go ahead and use the box method here, which should work. We now have two long things, so it actually doesn't matter what goes on top. I'm going to put the first thing on top. I'm going to put the second thing on the side. And now it's a 3 by 3, is it not? So multiplying for the top left would give us negative 3x to the fourth, I do believe. Over here it would be positive 10x to the third. Over here it would be negative 8x squared. In the next box, it would be 6x to the third. Then over here, it would be negative 20x squared, I do believe. And then we have 16x, I do believe. Then we have negative 3x squared. And we have positive 10x. Then we have negative 8. Now, once again, diagonal relationships, maybe. Yep, we have a red relationship. We have a green relationship. And we have a blue relationship. So negative 3x to the fourth all by itself. The red relationship gives us a 16x cubed. The green relationship would give us negative 31x squared, unless I'm not doing it right. Let's see. Yeah, I think that's good. The blue relationship would give us plus 20x, and then finally we have negative 8. So that's that. Next slide. Okay, decide whether each is a monomial, polynomial, trinomial, or none of the above. Okay, so quick review of some of the rules, right? If the degree meaning the exponent is 0, we call it a constant. Like that. If the degree meaning the highest exponent present in the polynomial is 1, we call it linear. If the highest exponent in the polynomial is a 2, we call it quadratic. So for my student watching, please remember that. If the highest exponent is a 3, we call it a cubic. If the highest exponent is a 4, it's a quartic. That should be decently easy to remember. A quart, hopefully you have that association with 4. If the highest exponent is a 5, we call it a quintic. That one's a little trickier. Okay, number of terms. If there is only one term, we call it a monomial. If there happens to be 2 terms, we call it a binomial. If there happens to be 3 terms, we call it a trinomial. And then anytime you get 4 or above, they just start calling it a polynomial. All right, so decide whether each is a monomial, polynomial, trinomial. No room for binomial, huh? I'm wondering if that's a typo. I think it's assumed they're all polynomials, although it could be a degree 4. Yeah. Or it could be more than 4 or more terms, rather. I would be surprised if the teacher did not also want you to tell her if it's a binomial. So should we also report if it's a binomial? I don't know. You might want to play it safe by just sticking with the four options. Option one, option two, option three, and option four. Yeah, I don't know. I'm going to say play it safe. So anyway, that's a monomial because there's only one term, right? This is clearly a trinomial. There's three terms, right? So, that's present right here, you know, trinomial. This is a binomial, but you know what we're going to do? We're going to play it safe. I hate to say it, but we're going to say none of the above. You got to play safe sometimes, okay? And then monomial, because it's only one term. Did we satisfy the directions? Decide whether each is a monomial, polynomial, trinomial, or none of the above. Yeah, I mean, as far as the directions that are written, we satisfied those. Okay. So over here, classify each by degree and the appropriate type of polynomial. So in other words, they want the first word. There's going to be two words for each. Okay. The first word is one of these, comes from this column, and the second word comes from this column. So for my student watching, yes, unfortunately, you do have to memorize crap. Okay. You have to memorize this stuff. But it is what it is. So over here, we have a cubic because of the degree monomial. Over here, we have a quadratic trinomial, which is quite common in this level of math. You're going to have to deal with those. Over here, we have a linear binomial. Over here, we have a cubic binomial. And I do believe we satisfied the directions completely. Classify each by degree. Yes, we did that. And the appropriate type of polynomial. Yes, we did that. Find the perimeter. Hopefully, my student watching understands, well, okay, if that's 3x plus 5, that's 3x plus 5. If that's 3x minus 5, that's 3x minus 5. Now, perimeter is nothing more than adding the side lengths. So for my student watching, I think she knows, yeah, you could just set up a long, clunky thing like this. And that's going to be the perimeter, okay? It turns out that this is a like term, blue underline. We have the green double underlines are constants. So the blue underlines would turn into 12x, and the green underlines, I think, would cancel. So I think we're stuck with that, to be perfectly honest, right? Because wouldn't this cancel with that one? And then this 5 would cancel with that one. So for my student watching, I think you would agree with that. I do not see an issue with these, so moving forward. Okay, is the following a polynomial? If not, why not? Only give a reason if it's not a polynomial. Okay. Okay, so here are the rules for polynomials. So let's kind of take a look at them before we even dive in. Only addition, subtraction, and multiplication are allowed. Okay. Variable exponents must be whole numbers. So in other words, the exponents hovering above the variables must be whole numbers like that. It can't be like a 1/2. Okay. This is bad. All right. Variables cannot be in denominators. So in other words, if you see a term that has like a variable down below, then it's not a polynomial. Okay. By the way, whole numbers. This implies that the exponents hovering above the variables, whole numbers, it's implied that it's zero or positive. Okay. So in other words, you cannot have negative exponents. And for the record, negative exponents would result in this situation. But just know that whatever the exponents are, they must be positive. Okay. Variables or zero. Okay. Now, in that case, it would be a constant. Okay. Variables cannot be inside radicals. Okay. Yeah. So you cannot have something like this, but it also can't be inside absolute value symbols. So you can't have any variables that are inside absolute value. And the expression must have a finite number of terms. That's probably something you don't have to deal with as much, but sometimes in upper level math, they might do a thing where they do a little dot, 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 and then it like goes forever, x to the n minus one or something. I don't know. So sometimes it might go forever. So you don't want to deal with anything like that. Are there any violations of those rules here? No. All of the exponents are whole numbers. There's no variables in the denominator. So is this a polynomial? Yes. We have a negative exponent here. So this is not a polynomial. So what could you say? You could say the x to the negative 3 term has an exponent that's not a whole number. Now, it's possible the teacher would also accept you saying that the x to the negative 3 term has an exponent that's negative. Okay. So it's possible either of these explanations would work. Okay. So this is a problem because that's an exponent that's not a whole number. Okay. So we could say, the 4x to the m term has an exponent that's not a whole number. So that's a no. All right. So hopefully that makes sense. Now, for my student watching, your teacher may have given you sort of like very specific wording here, but according to these rules, I just based it off of these rules, and I think this makes sense. Okay, so hopefully that's helpful. So anyway, hopefully for other students watching, it was also helpful, and I will talk to you all later. Bye.